strength of that material and strength of the joint both are almost same. So therefore strength of joint will be same as that of the base metal. But we do have some disadvantages or limitations with respect to welding is concerned. What are those means? You might have observed in the general workshops where welding is carried out. In such workshops you might have seen, say, while welding, harmful radiations are going to be emitted. Harmful radiations. So they are harmful for the eyes. So therefore we cannot see them. We cannot see the welding process by naked eye. We have to use goggles, that too coated goggles, so that it will not, the harmful radiation will not penetrate through it. So therefore that is the disadvantage of that harmful radiation it emits. So we have to take utmost care to protect the welder. Next, residual stresses may be set up in the weld joint. This also I explained. Residual stress nothing but stress which is already present in the material. Due to welding, what happens? Some amount of stress is going to accumulate within the material. So that is called as residual stress. This residual stress we have to remove it. How means? By means of proper heat treatment process. So therefore that heat treatment process is called as stress relieving heat treatment. Stress relieving heat treatment. This heat treatment topic already I studied in your third semester subject material science. Okay. So by here, what is that stress relieving heat treatment? Means we are going to heat the metal up to lower critical temperature. Lower critical temperature means that is a designation of that is A3 temperature. It is in case of steel, it is 727 degrees centigrade. Up to 727 degrees centigrade or below that 500 degrees centigrade, 600 degrees centigrade, like that we are going to heat the metal and then slowly heating the metal, then slowly cooling the material so that it will relieve the internal stress or residual stress which is imparted into the steel during welding. So that residual stress is the major problem in welding. Then skilled operator is definitely required, because if the welder is not a skilled one, it is very difficult to weld the joints. It is very difficult to weld the joints. So therefore, that is the skilled operator, skilled labor is required to do the welding. Structure of the weld portion will differ from parent metal. What happens? The weld, say this I will show you with the help of this diagram. See here, this is the diagram of welding. This presentation is also available in the your Teams file section. You can download this also. See here, these are the two metals. This is the one metal part and this is the other metal part. These two metal parts we need to join them. To join these two metal parts, so this is the welding process we have adopted. So this is called as the joint. This is called as the joint. This is the base metal or parent metal. This is also parent metal. This is called as the welding electrode. Those things we will discuss in the next topic. So, but here you should know what is the meaning of base metal. Base metal means the metal which is being welded, or the parts which are being welded. That is called as the base metal, and this is called as the joint. This is called as the joint. Okay. So here, sometimes due to severe temperature developed, you know what is the temperature developed during welding here? Within short period of time, within short span of time, the temperature developed in this region would reach somewhere in the 4000 degrees centigrade, 5000 degrees centigrade, or 3000 degrees centigrade, like that. So that is the very high temperature it will reach. Why? How it will reach means it is a process of that is by means of using electrode. So the here electrons jump from electrode to the base metal. That process I will explain you in the next topic. So during that time, the heat, enormous amount of heat is generated. The major problem is that only when enormous amount of heat is generated, then it will induce stress and it will change the microstructure of the material in this area. In this area, it will change the microstructure or structure of the material. So therefore, this material structure, definitely it is different from after welding. This is different from this because this is severely heated. and rapidly cooled. So therefore, in order to homogenize the structure, we need to homogenize the structure of this material, this joint, and this material. Everywhere the structure should be same for proper application. Therefore, this entire material is to be heat treated or tempered. This is called as tempering process or heat relieving process. It has to do we have to do the heat treatment process or heat treatment operation or tempering process is to be carried out. So now these are the advantages and disadvantages of welding basically, and applications are already we have discussed in the previous class. They are used in every part, and it is the welding, it has become the part and parcel of our life. So just like plastic what we see everywhere, like that welding also, it has become compulsory or it has become widely usable at every point. So whether you go to construction of the house, welding we need. Whether you go to construction of or bridges, we use welding, or building of the vehicle body, anything you take for that matter, everything or every application, every engineering application, now we have it, they are connected with the welding process. So this is the basics of welding. Now next topic, let's go to the classification of welding, that is welding processes. So this diagram is given to classify the welding process, or this diagram is also available. This classification is also available. Whichever you want, you can refer. See, either this method of classification or this method of classification. So both are available. You can use either. So now, any doubts till now, new students? Because some of the students may be new now. So if at all anything is there to clarify, you can clarify now. Any doubts, dear students? Yes or no? No doubt. Doubts are there or no doubts? Ashwini, you should spell out first. Okay. Then I will understand that you don't have doubts. Okay. So now let's go to the classification of welding. Classification, nothing but different types of welding. What are different types of welding? How do we classify the welding? See here, there are about 35 different welding and brazing processes, and several soldering methods are in use by the industry today. So different welding processes are there. Normally what we see, if you observe, if you while walking, you might have seen on the roadside general workshops, they will keep on welding. So that time if you observe, so that is welding, nothing but only that we understand. But here it is mentioned that there are about 35 different types of welding processes. So now we will see what are those welding processes. How they are classified? Weldings are classified on different grounds. On different grounds, weldings are classified. What are the grounds on which the weldings are classified? Mainly on the basis of heat source. Mainly on the basis of heat source, the weldings are classified. Based on that, we will see now here. Classified on the basis of source of heat, that is electric welding, gas welding, etc. Then type of interaction. Type of interaction means liquid, solid, etc. Okay, liquid state welding or solid state welding, like that. So depending upon the type of state of the matter, liquid state welding and solid state welding, and depending upon the energy supplied, source of heat, so different types are there. So those types we are going to discuss now. First one is, we can see here, gas welding. All of you might have observed about the gas welding. You at least few might have seen about the gas welding and process of gas welding. Normally, to weld, to join very thin metals, very thin metals, this method of welding is used. Gas welding is used. Just like making of almirah, you might have seen almirah using metal sheets. So that almirah, that sheet is, the sheet thickness is very small, like 0.1 millimeter, 0.2 millimeter, 18 gauge, 20 gauge. That is the thickness of the material. That thickness of the material, it is not possible to weld by different other methods. Therefore, gas welding is most suitable for that purpose. So therefore, gas welding, different types are there. What are those? This in detail, we will discuss all those things later. In this class, just today, you will try to learn what are the different types. Air acetylene welding, air and acetylene. Acetylene is the gas, combustible gas. Air is the supporting gas. So therefore, air acetylene welding, oxyacetylene welding, oxyhydrogen welding, mainly these three. Okay. Then one more is pressure gas welding. So mainly oxyacetylene gas welding is widely used. Next comes oxyhydrogen welding. Normally, in all general workshops, we will see oxyacetylene welding. Okay, acetylene welding. Two cylinders are there. They are connected, and then combustion or the heat is generated. That we will discuss later stage. Totally, gas welding nothing but these classifications you should remember within the gas welding. Next, arc welding. Arc welding nothing but it is by me the energy supplied is the energy source is electrical source. Energy is primary source of energy is electrical energy. So one second. Primary source of energy is electrical energy. So within this arc welding, there are so many classifications you can see. All these types we will not study here. Few types we will study here. Rest of the remaining type of welding, if you take elective subjects in your higher semester, you can study those all the types. Okay. Here the important ones are general ones we will study here. Arc welding. What are the arc weldings means? Carbon arc welding, shielded metal arc welding, flux coated arc welding, submerged arc welding, TIG welding. TIG nothing but tungsten inert gas welding. Yeah, tungsten inert gas welding. It is also called as GTAW, gas tungsten arc welding. Okay. MIG welding, MIG nothing but metal inert gas welding, and plasma arc welding, electro slag welding, electro gas welding, stud arc welding. These are all the variety of weldings. Just try to remember these names under this arc welding. All the types we are not in detail studying. We are studying only few in detail how the welding is done. Okay. Next is resistance welding. This is also electrical energy. Resistance welding is also using electrical energy is the source of energy. What are the types of resistance welding means? Spot welding, seam welding, projection welding, resistance butt welding, flash welding, percussion welding, high frequency resistance welding. These are all the different types of resistance welding classifications. Solid state welding. Here you must remember up to this classifications 1, 2, 3. Previous gas welding, arc welding, resistance welding. Here we are liquefying the metal and then welding is being carried out. During welding, metal is being liquefied. But in this case, solid state welding, the metal, two metal parts will be in the solid state itself. Therefore, they are called as solid state welding. Different types again you can see: cold welding, diffusion welding, explosive welding, forge welding, friction welding, hot pressure welding, roll welding, ultrasonic welding. These are all coming under solid state welding. That is, joint is made in its solid state itself. Metals, solid state itself, welding is carried out. That is called as solid state welding. Then one more is thermochemical welding process. Thermochemical welding means thermite welding, atomic hydrogen welding. Okay, this is another special category of welding. Radiant energy welding process, electron beam welding and laser beam welding. See, all these things, different types of energy sources, different types of welding classifications. Just you try to remember these names, okay, in this section. So next we will be keep on discussing one by one as per our requirement, that is as per the syllabus. Whatever it is mentioned in the syllabus, that we are going to study, and apart from also some assignments and other quizzes we can see in these pertaining to these topics. Okay, some assignments we will see on this remaining topics. So these are the different types of different classification of welding. I think there is no doubt here, nothing, no explanation, because it is only the classification, naming different types. That's all. This is the way of classifying. You can see the other way of classifying welding process, cast welding. So don't worry about all these things. You practice any one of the welding classification, whether this diagram type or this type, whichever is comfortable, that you can do it. Better, this is easy to understand. Next, already we have seen the advantages and disadvantages. Practical application of welding we have seen. Okay. Before welding, before carrying out the welding process, see, these are the two metal parts. Already I had shown in this diagram, first diagram here. This is one metal part, part A, and this is part B. Simply we cannot take these two parts and start welding at the joint. This is the joint. Along the joint, you cannot simply start welding. You need to prepare the material for welding. Anything before going to test, you cannot simply go. You have to prepare and go to the test or examination. Or before coming to college, you have to prepare yourself, get ready, and then come to college. Like that, the metal, before starting welding, we have to prepare the material suitably. How we can prepare the material means, for example, this is also flat material, this is also flat material. Then the edge it is straight like this. It is having straight edge here. There is no gap. There is no gap between when these two parts are joined together. There won't be any gap between this part A and part B. Then welding cannot be done effectively. So therefore, what we have to do is we have to chamfer, nothing but cutting the material like this. See, preparing the groove like this. We have to groove the material like this, prepare the groove like this, so that there is sufficient opening. There is a provision for filling of the liquid metal during welding process. Therefore, what happens? The proper strong bond will be developed between joint metal A and metal B. So therefore, then the joint will be equally stronger like the base metal A and B. So therefore, we have to prepare the joint, that is called as joint preparation. How to prepare the joint means we will see that here. These are different shapes of edge. This is called as joint preparation or edge preparation. See, initially the metal parts will be like this one and this one. And next we have to prepare the metal parts like this. If the metal thickness is less, if the thickness of the material is less, then we can go for only one side edge preparation, like 60-degree chamfering. See here, this is called as chamfering. This is called as chamfering. So one side chamfering is done. If the thickness is less than 10 millimeter, you can see. Thickness is less, one side chamfering we can do. And there must be a space, small gap between metal A and metal B, so that liquid metal easily enters into and fills all this gap, so that proper bonding will be obtained. If the metal thickness is greater, very bigger, that is 12 millimeter, 15 millimeter, very big, then this type of arrangement or preparation can be done on both sides. See, one side and two side. Both side preparation or both side chamfering has to be done. It has to be cut like this. Then joining so that liquid metal fills this, liquid metal fills here, so that the proper joint will be obtained. Or the other method is also mentioned here. You can see this one side we can do, the others here single side, here double side. Thickness is more. And this is one V shape. This is called as V groove preparation. V shape of groove preparation. And this is U shape. See, U shape groove preparation like this. Okay, same like this. Thickness is less than one side. If thickness is more, then it has to be done on both sides. Same like we here also a half U, then half U on both sides. Like that, we have to prepare the metal or joints before going for actual welding practice. Okay, and it has to be dust free, dirt free. No oil or no dust, nothing should be there. Everything should be properly cleaned before going to welding. That is the prerequisite required to do the welding. Okay. See, these are the edge preparation simple diagrams. Edge preparation simple diagram, you can look into it. Okay. Now, so this is classification. Already I explained with the other in the PPT. You can study that. This is the welding classifications. Next is arc welding. We are going to study about arc welding process. Okay, what is arc welding? Any doubts till now? Any doubts till now?
No, sir, no doubt. Understood.
Remaining students? Any clarification? Any doubts are there? Srijan?
No doubt, sir.
No doubt, sir.
Okay.
No doubt, sir.
Syed Vigneshan ji? I think.
Not doubt, sir.
Who is that? Vignesh? Okay. So now let's go to the next topic, arc welding process. It is the very simple general welding process what you and also you have experienced it or experienced nothing but at least by seeing. You all of you have seen welding process in the general workshops where fabrication work is done. Fabrication nothing but manufacture of the preparation of gates and compound gates, rolling shutters, etc. They are going to prepare now. So there in such shops, definitely you have seen the arc welding process. What is arc welding? What is the meaning of arc? That we try to understand in this class now. It is a fusion welding process. What is the meaning of fusion welding? Fusion nothing but we are converting the solid metal into liquid state. We are converting the solid metal into liquid state. See, this metal is solid initially. So we are converting this portion of the material here. In this region, we are converting this metal into liquid. Okay. At what rate? At very rapid, instantly. When this is called as electrode. When this electrode comes in contact with this, immediately within fraction of seconds, the temperature will be developed to severe temperature like 3000 degrees centigrade or 4000 degrees centigrade. So immediately this metal melts. So then it is converted into liquid metal. Here, when two parts, for example, to the left side of this one part, here, left side one part and right side one part. When these two parts become liquid at this junction, when these two parts become liquid and they are allowed to cool. So then they jointly cool. Jointly, this metal, end of this metal and end of this metal, they jointly cool so that there will be exchange and bonding will take place between the two metal parts. So that is how the bonding will be created between the two metal parts. You can see in this diagram, this part and this part, in between the liquid metal has filled by means of arc welding, so that this is the metal, this metal composition and this metal composition both are same. This metal composition, whatever welding material, and this metal which are joining, both are having same composition. If this is mild steel, this is also mild steel. If it is brass, this is also brass. Copper, copper. Like that, the welding has to be carried out. Okay. So therefore, that type of this the arc is produced. Now let us see what is arc. It is a fusion welding process. Fusion, nothing but the solid metal is converted into liquid metal by supply of electric energy or by means of electrical energy, so that arc is produced. Due to that arc, the metal melts, or the severe temperature is developed. Due to that, the metal, solid metal is converted into liquid state, so they are allowed to cool. So when they are allowed to cool, these two become union or one joint. So this is what happening in case of arc welding. It is a fusion welding process. Here, an electric arc is used as the heat source. Electric arc is the main heat source. An electric arc is what is the meaning of electric arc? It is a continuous stream of electron flowing between two electrodes from positive to negative. Okay, continuous stream of electrons flowing from positive to negative, continuously flowing or jumping. Okay, jumping of electrons from positive to negative continuously takes place. Therefore, it is called as stream. Okay, due to this stream of electrons, they are hitting the workplace. They are targeting the workpiece at a greater velocity. Therefore, intense heat is generated. Intense heat means very severe or higher heat amount of heat is generated at the junction where it hits the workpiece. See here, this is the electrode. Now, this is the electrode, and this is the base metal which is being welded. Okay, so when the current, this is connected to positive, this is connected to the negative. It is connected to earth actually. Negative nothing but it is connected to the earth. So therefore, energy comes to this, and the electrons jump from this electrode to this part. See, that is the flow of electron you can see here. So because of this jumping of electrons, what is happening? Severe amount of heat is generated in this location, at the limited location. Because of that, enormous amount of heat is generated and metal will be melted in that particular region. Hope all of you understood this. Okay. And here what happens, once the metal melts, as I already told, metal A and metal B both are melted. Then cooling of those two pieces takes place together. So then that is called as joining. So now here you can see what are the other terminologies. This is the electrode, this center portion. You can see the hatch. This is called as the electrode. And outside, electrode coating. Electrode nothing but the base. Here, this material, this welding material, and this welding electrode, both are same composition. That is why both, you can see this material and this material both are same. To protect this welding rod or welding electrode, outside there is a coating. Outside there is a coating called as electrode coating. It is called as electrode coating. Okay. Next is the gaseous shield. This is called as the gaseous shield. Shield means protecting layer formed by means of gas. Okay. because of the heating welding process, gas is produced. That gas protects the liquid metal from reaction. So therefore, this is the gaseous shield. This is the base metal, and this is called as the crater. Crater. A depression is produced, a ditch is produced. That is called as the crater. That crater is produced due to jumping of electrons, and this is called as the slag. Okay, this is called as the slag. Slag, nothing but impurity which is floating on the liquid metal, and this is the molten metal which is here, and this is the arc stream. This is the electrode. So this is about today's class, because we are reaching the time. So today I'm going to stop this class at this point of time. So now it is nearly 3 o'clock. So any questions are there, you can ask now. The session is open to you. So you can ask questions on the topics what we are. This we will continue in the next class also. You remember this diagram for arc